Uh, good evening, everyone. It's good to see you again. I hope you're doing well. Today, we're going to continue solving another problems of the Archimedes principle. In this situation, we were talking about according for spherical balloon, weather balloon, as a matter of speak. Okay, so we have a spherical weather balloon that's supposed to be filled with hydrogen until its radius is 3 meters. Its total mass, including the instruments it carries, is 15 kilograms. So we have two questions. The first one, they're asking for what will be the buoyancy force or the buoyant force acting on the balloon, assuming the density of the air is 1.29 kilograms per cubic meters. Why we are using the density of the air? Because the density of the air acts like a buoyancy force. That will be the elements which provide us. The balloon will be moves over. I mean, there will be float in air. All right. And actually, the hydrogen acts like some kind of way which that provides stability in the water balloon. Hydrogen provides stability in the air that causes the balloon moves over. That's why the problem gave us the value from the density. So what is the first thing that we must to do? Always, 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 because we're going to solving the letter A, and after that, we're going to solving the letter B. The first thing that we have to do, always create a picture of the problem. Remember, this is a spherical balloon who has the other tools and edges, okay? And this balloon moves over according to the problem says. And you know, the moment where because it's located at the same side or the same position of the force, that the force that's supposed to be positive, okay? Now, let's go to trying to looking for what will be the first question. The first question is, okay, find what will be the value for the buoyancy force. Do you remember what is the equation for the buoyancy force or buoyant force? Yeah, that will be equal liquid density submerged volume times gravity, okay? But in this case, there is no liquid. We're talking about the air. The formula we have to use will be the same, but instead to say liquid, we're going to use gas because air is a kind of gas, right? So in the first question, they're asking for buoyancy force, FB, density air, volume. I'm not using submerged volume because this is not under water, under any liquid, only volume and multiply by the gravity. This is the formula that we're supposed to use in the first question. But basically, we have to looking for what will be the volume and what is the shape of the spherical water balloon. What is the shape of that one? That sphere. So we must use the formula for the volume of the sphere. And you know, the volume of the sphere will be given by BE equals 4/3 pi cubic radius. Okay. Now let's go to replace that value. Will be 4/3 pi, and the radius is 3 meters, right? 3 meters at the cubic power. For that reason, the volume from the sphere will be given by, please give me a hand, 4/3 pi times 3 at the cube power. Hmm? Chiv, Chiv, yep. Parentheses 3 at cube power. Cube power. That will be 113.1. 113.1 cubic meters. This is going to be the volume of the sphere. Well, it's time. This is the moment go through. Let's try to looking for what will be the buoyancy force. So FB equals density of the air, right? The density of the air will be given by 1.29 kilograms per cubic meters. This is by one hand. By the other hand, the volume of the sphere, calculated already, that will be 113.1 cubic meters. And finally, the gravity, you know, the gravity has a constant value of 9.8 meters per second square. So the buoyant force, buoyancy force will be given by 0.1 times 9.8 will be 1.43. No, 1,000. 1,429 point what? 0.81. 81. And that will be provided by newtons. Okay? Understood up to this part? Understood up to this part? We have a question. Excuse me? The formula for the volume of the sphere, remember the spherical weather balloon. Exactly. Spherical balloon, spherical sphere. That's why. We have the first question. Now, in the second question, they're asking for what will be the net force acting on the balloon and its instrument after the balloon is released from the ground. Okay. In the second question, to solving the second question is so necessary to create a free body diagram because we have to analyze what will be the position for every force. So we have the coordinate plane. We have the coordinate plane, you know, this is y, negative y, x, and negative x. Okay, let's see to analyze where's gonna be every force. The first one is the buoyant force. Buoyant force, where's supposed to be the buoyant force? Over, right? So over. FB. The FB will be the first one. The second force, the weight of the what? The weight of the entire balloon. And not only the balloon, including the instrument, something like that. Okay, I'm going to use WB. B represents the balloon. What else? What else? Because we have another force, including this weight. Any idea? Well, the air, remember, the air is part of the buoyancy force. But remember, this spherical balloon is filled with hydrogen. That hydrogen provides some kind of weight to stability to the balloon. So that gas has their own weight. But that reason, that weight will be located downward because it's a weight. And I'm going to establish the difference between them because instead to use WB, I'm going to use WH, that way of that gas, as a matter of speaking, okay? Understood under this part? Buoyancy force, the weight of the balloon, and the weight of the hydrogen, okay? So that's time to create the addition of forces. Remember, I'm going to use the purple one. the addition of y forces over positive, that will be equal to, okay, I have a question for you guys. The balloon is at rest or it's moving? It's moving up, right? We're upward. And the problem never said moving a constant speed, said moving up, upward. For that reason, because the balloon is moving upward, the system equation, instead to be equal to 0, will be equal to what? Second law of motion. Because we don't have a constant speed or velocity, we're supposed to have acceleration. Second law of motion, the quantity force applied for any object that will be equal to the product between mass times acceleration. This is going to be the net force. So instead to be equal to 0, because the balloon is moving upward, it's moving. This is not a static, this is a movement. I'm going to equal to mass times acceleration. The difference between the last problem we solved yesterday, where we have the table tennis ball. Do you remember that one? That was static because we're holding up. And then, well, in this case, the balloon's moving upward. That's why we are equal this equation by mass times acceleration. Understood? Okay, then. Say it again. Amen. Remember mass times acceleration because it's moving upward. This is not a static. Yeah, that's simple because it's just moving. That's the main reason, because the balloon is moving upward. That's why. Now, let's create an equation. The first one, FB, will be positive, FB, minus the weight of the balloon. Why is negative? Because look at it downward. The weight of the balloon. And also, we got the weight of this gas, the hydrogen. And because I'm not interested to trying to looking for what will be the mass or what will be the acceleration, remember that postulate the second law of motion established that force can be calculated multiplying mass times acceleration. The name of this force is not net force using the second law of motion. Yes, Sylvia? You don't have questions to this part? No, okay. So instead to write MA, I'm replaced by the net force because it's the postulate of the second law of motion. If you wish, you can write only F or adding the letter N, that means net force. Okay, what is the value from the buoyancy force? 1,429.81 newtons minus what is the mass of the balloon and the tools? That will be 15 kilograms, right? 15 kilograms multiplied by the gravity, that will be 9.8 meters per second square. Okay, minus the weight of the hydrogen. Yes, all right ahead. Mass of the hydrogen multiplied by the, yes. Say it again. What is the formula from weight? Mass times gravity. Remember, weight equals mass times gravity. That's why. And same happens over here. We know what is the mass, we don't know what is the mass of the hydrogen, right? But we know what is the value from the gravity. 9.8 meters per second square. And this entire equation will be equal to the net force. We have a serious problem here, right? Because we can simplify this expression. We got 1,429.8 newtons minus, please multiply 15 times 9.8. We can reduce that equation. That will be 147. 147 newtons. But unfortunately, I don't know what is the mass of the hydrogen. What we can do to find out the mass of these hydrogen? Any ideas? Any ideas? Exactly. We must use the formula from density. Remember, density equals what? Density equals mass over volume. Okay. Do we know what is the value for the density of the hydrogen? Of course we know. We know what is the value from the volume? Of course we know. That will be the same value of the sphere because sphere is filled around the balloon. So the volume of the balloon will be the same value from the hydrogen. So basically density times volume will be the mass of the hydrogen. So the density is 0.0899 kilograms per cubic meters multiplied by the volume, and the volume will be given by 113.1 cubic meters. And this is going to be the mass of the hydrogen. All right, give me a hand. 10.17, 10.17 kilograms, right? So now we are fully prepared to do it. Let's simplify that equation. I mean, parentheses, 10.17 kilograms multiplied by 9.8 meters per second square. And this is going to be the net force. Please perform this entire operation. 1,429.8 newtons minus 147 minus, or if you wish, you can simplify that one and at the end, subtract all the terms. Let's do it step by step. Let's do it step by step. 1,429.8 newtons minus 147 newtons minus, please multiply the last two terms, the last two one, 99.67. 99.67 newtons, and this is going to be the net force. Please give me an answer, a final answer. Will be 1,182, 1,182.33. And this, my dear students, will be the net force that the problem asking for. Do you have some doubts or questions until this far, or everything's clear? Remember, the difference with this problem versus the last one that we made yesterday is the last one, the table tennis ball was addressed because we was holding up underwater, and this balloon is moving upward because this is keeping the movement. That's why we are equal to mass to acceleration instead to 0. Got it? Okay, then. Let me know when you finish to copy the problem. And let me pause the video. Oh, okay. In the second example, this is an interesting problem. Let's see what the problem mentioned. We have a cube of wood having an H dimension of 20 centimeters or 0.20 meters, and density of 650 kilograms per cubic meters, floats on water. Floats on water. Letter A. What is the distance from the horizontal top surface of the cube to the water level. We're going to solving the problem by the two questions. Let's going to start for the first question. Again, what distance from the horizontal top surface of the cube, from the horizontal top surface of the cube to the water level? The meaning is the volume of this cube is not going to be totally submerged, according to what the problem says. Let's going to create the picture of the problem. Let's going to drop the cube. Okay. Okay. This is the cube, right? And this cube, that's supposed to be some part of this cube that's supposed to be submerged in water. This is water. According to what the problem mentioned. This is the water, this is the cube, okay? And you know, every edge of the cube had the same measure, 20 centimeters or 0.20 meters. But if you see the picture of the problem, the distance between this edge onto this part, that will provide it by, we can say X. X represents the edge of the cube. However, this some part of this edge of the cube is in the air, and the rest that's supposed to be on water. Well, this is going to be the edge that the problem asking for. What will be the distance from the horizontal surface to the horizontal surface of the cube to the level of water? That difference, this letter H level. Let's see it a little bit better. This value from H. This is what the problem asking for. All right. So what is the first thing that we must do? Always, always, always will be what? Free body diagram, always. If the same, free body diagram. Let's create the free body diagram. I mean, we have the coordinate plane over here. Okay. We have y, negative y, x, and negative x. What forces do we have in this case? Obviously, the first one will be the buoyant force that will be located upward, right? FB, the buoyant force. And what else? The weight of the cube, simple. This is what we call that one WC, which represents the weight of the cube. And that's it. There's no more elements that we're going to barrier the problem. So basically, the cube is not moving. It's just at rest. It's only floating on water. Okay. So because this is we have the same position is at rest, let's going to start with the addition of the buoyancy force. I mean the addition of y forces. Addition y forces upward positive in this case will be equal to 0 because there is no movement in the cube. It's at rest, right? What forces do we have? We have obviously the buoyancy force positive minus the weight of the cube. That will be equal to 0. Okay. Now, what is the formula from the buoyancy force? Remember the liquid density. In this case, the liquid density will be water, right? The submerged volume multiplying by the gravity, right? Subtracting the mass of the cube multiplying by the gravity and the entire equation that will be equal to 0. So, but we have some kind of situation. We have no idea what is the mass of the cube, right? The problem never gave us the mass of the cube. They gave us the value from the density. And remember, because we are starting to repeat the same formula, Remember that formula can be calculated, the mass on any object can be calculated multiplying the density times the volume. Yes or no? Because density equals mass over volume. So solving for mass, we have density times the volume. Okay, let's going to replace that value over here. We have the density for water, submerged volume, gravity, minus. Instead to write MC, we're going to replace by the density of the cube, volume, and gravity. That will be equal to 0. But even though we are replacing those formulas, we can establish one singular condition. In this problem, as soon as you can see, the submerged volume is totally different than the original volume because some part of the cube that's supposed to be submerged or located underwater. The real problem is which part, what will be the percentage of that part, or what could be the size that's supposed to have submerged underwater, and what will be the part on flood, I mean in the air. So we have to create a little relationship. First of all, the easier part is locate what will be the volume of the cube. I mean the real volume. Okay, the volume of the cube, remember, because it's a three-dimensional geometric shape or geometric figure, is x at the cube power, right? The letter x will represent the measure of the edges, right? So the volume of the cube, the original one, there's no inconvenience. However, in the submerge of the volume of this cube, only one of these edges, this is not completely submerged. One of these edges, right? Remember, you can take this edge, so this part is not completely submerged, right? So in math, if we have x cubed power, if you really want to simplify that expression, we can write this expression like a x squared times x, right? Yes or no? X squared times x separately, because we need to, in the submerged volume, we need to separate one side or one edge of the cube because that edge is on air, in the air. I mean, instead to write x cubed, I'm going to write x squared multiplied by this letter x. This is a part of the area, but there's a one singular movement in this letter x. In this case, because we really need to know what will be the part is exposed on air, the only thing that I have to do is this letter x must be subtracting with this part of the h to find out what will be the part submerged in this volume. Okay, simple merely words. I'm going to open parentheses, and instead to write only the letter x, I'm going to subtract by h. Why x minus h? Because I'm talking about submerged volume. Can you see this part of the picture? So what will be the submerged part of the volume? Upward or downward? Downward, right? So if I subtract this letter x with this height h, obviously the difference will give us the submerged part. Got it? Got it? Yes, Marcela? Ah, solo estoy separando un ladito. Acuérdense que x al cubo es el volumen completo, pero como solo hay un pedacito del volumen que está sumergido, como que esa cara la separo para poder restar solo la diferencia. Dígame. Sí, times, multiplicando. Recuerde, x al cuadrado por x, ¿qué me da? X al cubo, ¿no? X squared times x gave us x cubed, right? The ley de los exponentes. Love of power with the same base. Copy the base and adding the powers. So, given that information, we got density of water instead to write submerged volume, I'm going to replace it by that equation. If you wish, we can use brackets. X squared multiplying by x minus h. Okay, close the brackets, multiplying by the gravity. Okay, and we can move this element to the left side. The subtracting passes to adding, and we got the density of the cube. And instead to use volume, what is the formula from the volume? X cube only, right? Well, X cube. And we got the gravity. Yes or no? Well, what happened if this letter G that is multiplying passes to divide? The G can be canceled, right? Yes or no? Well, we got density of water, brackets, x squared, parentheses, x minus h, close parentheses, equals the cube density, x cube. And by the way, this x squared is multiplying, right? What passes when this is multiplying? Passes to divide. So what's going to happen with the letter x? We can simplify this letter x, right? So we have x cubed canceled with x squared, and we have the water density multiplying by x minus h will be equal to the cube density multiplying by x. Why? Because this x squared that was multiplying when passes to divide, we can reduce those terms. Yes or no? Porque lo estoy dividiendo. ¿El qué cosa? Me preguntó. Pues sí, este multiplica aquí. Bueno, porque la gravedad multiplica, manda a dividir, o esto lo manda a dividir, siempre se va a cancelar, porque es la misma, ¿no? Este, aquí, ¿de dónde lo saqué? El volumen del cubo en el aire, es normal. El volumen del cubo, esta es la formulita. Uno le llaman X cubo, otro lo llaman L al cubo, otro le dicen S al cubo. Es el volumen del cubo, la fórmula. El lado, o sea, the H at the cube power. Esa es la fórmula from the cube. Ya está dada esta formulita. O sea, ya es una fórmula dada, la fórmula del cubo. X representa la medida del lado, de cada lado. Pues es que es el mismo. Pues si todos los lados son iguales, correcto. ¿Qué? Por eso, es lo que estamos, solo que está haciendo lo más pequeño, simplificándolo. Y mira aquí, podemos simplificar más. Observe, esta densidad del agua que multiplica pasa a dividir. Mire, X menos H igual la densidad del cubo por X entre la densidad del agua. Podemos reemplazar. Fíjense bien. ¿Cuánto vale X? Ya lo tenemos. Eso vale 0.20, ¿no? 0.20 metros menos H. A saber cuánto vale H. ¿Cuánto vale la densidad del cubo? 650, sí, que está al menos. 650 kilogramos por metro cúbico multiplicado por la X. ¿Cuánto vale X? 0.20, ¿no? Dividido entre la densidad del agua. ¿Cuánto vale la densidad del agua? 1000, ¿no? ¿1000 qué? 1000 kilogramos por metro cúbico. Y es más, mire, kilogramos metro cúbico pueden cancelarse. Please multiply 650 times 0.20. And when you have that answer, divided by 1000. Eso es 1000. 0.13, right? So we got 0.20 meters minus h equals 0.13 meters. Obviously, because we're canceled kilograms per cubic meters, and we have only meters. And we have in the easier part, right? Because this H is subtracting, passes to adding, this is adding, passes to subtracting. So simple merely words, 0.20 meters, subtracting 0.13 meters, that will be H. And the answer will be 0.07 meters. And this is going to be, my dear students, the answer from the letter H, what we are looking for. Well, in the next class, we're going to finish this problem asking the second question. Ujú. Este es el volumen de, espera, solo voy a cerrar el zoom.